So linear inequalities are inequalities in two variables whose graph is a region of the coordinate plane that is bounded by a line. So our inequalities now, instead of having an equal sign, we're going to have a less than, greater than, less than or equal to, greater than or equal to sign, okay? And we graph these linear inequalities because it's a visual way to show all the ordered pairs that satisfy the inequality. So with an equation, there's only certain pairs that would satisfy the inequality. Like if I plug in 3 for x, then the output y is going to be 5 or whatever. And that's the only answer I'm going to get. But with an inequality, it can be anything greater than that or anything less than that. So there's going to be a huge set of numbers. And we're going to graph these inequalities to visually show here's where the set of solutions are. Okay? So steps to graphing. Just like with a line, or a linear equation, you're going to rewrite the inequality in that slope-intercept form. So we're going to rearrange these and put them in that y equals mx plus b form. Then, when we go to connect the points that we have made, step number 2, when we graph this boundary line, if our inequality sign is just less than or just a greater than sign, then our boundary line is going to be a dashed line. So you're going to connect those points with a dashed or a dotted line to show that the points on that line aren't actually included because they have to be greater than or less than. If your inequality sign is less than or equal to or greater than or equal to, so now we are including those points, they have that or equal to statement, then the boundary line is going to be a solid line. So when we connect our points with these inequalities, you have two options for a boundary line, either dashed or solid. It is solid if it includes the or equal to statement, okay? Then, after we draw our line, we're going to shade a portion of the grid that includes all of the solutions. And if our inequality is like y is less than or at less than or equal to, then you're going to shade the region that's below the y-intercept. So we're going to shade the region of the grid that includes anything below the y-intercept, if it's a less than or equal to. So if our inequality is y is greater than or equal to, well, if it's less than, you shade below. When it's greater than, where do you think you shade? Above. So we would shade the region that includes above the y-intercept. Anything above the y-intercept, that's the region of the graph that we would want to shade. So after you decide if you're shading above or below in number 3, then your step number 4, the last thing you're going to do is actually shade that half plane. So shade the region of the grid that includes those solutions. So we're going to work through all 6 of these together so that you have plenty of examples, and then we'll jump into our formative. Number 1 is y is greater than negative 3x plus 5. So this inequality is already in that y equals mx plus b form. So I already know the slope, and I already know b, the y-intercept, and that's what I'm going to use to make some points here on my boundary line. So my slope is a negative 3, and then b, the y-intercept, is 5. So we're going to graph this just like we did at the beginning of the unit. We're going to go ahead and start at 5 on the y-axis. And then from there, we're going to make a couple more points by using that slope, which is a negative. So we're going to go down and right. So we make that decreasing line. So we're going to go down 3, right 1, plot a point. Down 3, right 1, plot a point. Now, before you go to connect those points, you want to look back at this inequality sign. Since this inequality sign is just greater than, you're going to connect those points with a dashed line. So we're going to connect those points with this dashed line. Yes.
What does it mean? Like, what's the difference between a line and then just that? Like, why do we have to?
Because the dashed line would show that, like, this point right here is not actually a solution to this. If I plugged in 1, 2, so if I plug in 1 for x, -3 times 1 is -3, plus 5 is 2. Well, 2 is not greater than 2. That's not a true statement. They're equal. So that's why we have this dashed line, because these points aren't actually included as part of the solution.
Oh, okay.
Now that we've created that boundary line, we need to decide, if this is the boundary line, where do we shade this grid? So because this is a greater than sign, we're going to shade above that y-intercept. So this y-intercept is pretty high with this grid, but above the y-intercept would be this region. So we're going to shade anything that's kind of towards the right, really, of this line. So we're shading this region of the grid to show, unlike with this point, if I were to plug in one of these points, like if I plugged in 3, 3, well, -3 times 3 is -9, plus 5 is 4. And the y value I would have plugged in was 3. No. What did I do here? 3, 3. Why is that making no sense to me right now? -3 times 3 plus 5 is -4. Okay, and so then yes, if your y was 3, 3 is greater than -4. So that is a true statement. Okay, thank you for helping me with my little brain fart that I was having there.
Brandon,
Yes.
I need Hope and Faith ring for checkout.
All right, they are on their way.
Thank you.
Okay. Okay. Let's try number 2. Number 2, we have y is less than or equal to 2/3 x minus 1. So again, this is already in that y equals mx plus b form, so we don't have to worry about doing any rearranging. The slope here is 2/3, and then b, the y-intercept, is the -1. So this is going to help us graph it. We're going to go to the y-intercept at -1, and we're going to put our first point. And then we have that positive slope of 2/3. So we need to make sure that that line is increasing as we look at it from left to right. So we're going to go up 2 and right 3. Or we could go down and left, because remember, those two negatives make a positive. Now we're going to graph our boundary line. But again, we're looking at this inequality sign. Well, this inequality sign says less than or equal to. So since it includes the or equal to, our boundary line is going to be a solid line. And then since it's less than or equal to, when we're deciding where we're going to shade, since it's a less than, we need to shade the area that includes below the y-intercept. So this area below the y-intercept is right here. So we'd be shading this region of the grid. And this is where all of our solutions would be, including those on the line, because now the line is solid. All right, the next two are a little different only because we get to practice rearranging. So number 3, I've got 5x plus 3y is greater than or equal to 12. This is not in that y equals mx plus b form, so we get to practice rearranging to get that y by itself. So what do I want to move over first when I'm trying to get this y alone? The 5x, very good. So since this is a positive 5x, How do I move it over to the right side? Minus it. Very good. So we are subtracting the 5x from both sides. So that now I have 3y is greater than or equal to negative 5x plus 12. Now, all I have to do to get y by itself is divide. Y is being multiplied by 3, so I undo multiplication by division. And when I divide, unlike when I subtract or add, when I divide, I have to divide everything by that 3. So that I get y is greater than or equal to, well, what happens when I do negative 5 divided by 3? It's just going to stay negative 5 over 3. Very good. So our slope is negative 5 over 3x. And then what do I get when I do 12 divided by 3? Very good. Once it's rearranged, it's just like what we did for numbers 1 and 2. So m, our slope here, is going to be that negative 5 over 3. And b, the y-intercept, is 4. So that b, that y-intercept, that tells us our starting point of our graph, 1, 2, 3, 4. And then from there, we're going to go down and right to create that negative sloping line. This line needs to be going down. So down 1, 2, 3, 4, 5 over 1, 2, 3. Now, when we connect those points, we're looking at that inequality sign. It is greater than or equal to. So since it includes the or equal to, we've got a solid line. Sorry that is sloppy. And then since it's greater than, we're going to be shading above. So here's my y-intercept. The region above the y-intercept would include these y values. So it's this right side of my graph that I'm going to want to shade. That's the region that I need to shade. All right. We've got one more that we're going to rearrange. Number 4, we've got x minus 6y is greater than negative 12. So remember, if there's not something in front of the variable, it's a 1. Okay? But still, we're rearranging this so that we can get that y by itself. So just like we did before, the first thing we want to do is bring that 1x over to the other side. So since it's a positive 1x, I'm going to move it over by subtracting the 1x. So that I get negative 6y is greater than, these are not like terms, so I don't combine them, negative 1x minus 12. Now, all I have to do to get this y by itself, y is being multiplied by negative 6. So I'm going to divide by negative 6. And again, when we divide everything. So this cancels out, and I'm left with y. Now, think back to when we did like solving inequalities, and we had the number line and like the open and the closed circle, and you shade to the left or the right. And when we were solving those inequalities, we had to do something with the inequality sign when we divided by a negative. Well, that's still true. Anytime you're dealing with an inequality, if you divide by a negative like we did with this negative 6, to keep the inequality true, you have to flip the sign. So now, all of a sudden, we have y is less than. And then we can go ahead and do this division. When you did negative 1 divided by negative 6, that simplifies to what? A positive 1 over 6. And then negative 12 divided by negative 6 is plus 2. Negative divided by a negative is a plus.
Oh, I didn't-
Okay, so now here is our inequality in that y equals mx plus b form. Y is less than 1/6x plus 2. So m, the slope, is 1/6, and b, the y-intercept, is 2. So we'll put that first point on 2. And then from there, we can go up 1/6 to the right. Or we could go down and left. We are going to check out this inequality sign. Since it's just less than, our boundary line needs to be a dashed line. And since it's less than, we're going to be shading below. So here's my y-intercept. Here's where below my y-intercept would be. So that means I'm shading this entire part of the grid there. So really the only thing new we're doing here in this section is my boundary line dotted or solid? And then am I shading above that line or below that line? Like which part of the coordinate plane am I shading? Okay? The last two, these will be super quick because number 5, these are our special cases lines that we can't ever forget about even though we've already tested on them. Y is greater than 4. We only have one variable in this problem, just y. It's not like y equals 4x. It's just y. So when I just have a y, what kind of line is that? Horizontal. Very good. Remember that hoi vux. Anytime you just see one variable, you have to remember that hoi vux. So since we have the y equals, that's going to be horizontal. It's a horizontal line that goes through the y-axis at 4. But if its y is greater than, that horizontal line needs to be a dashed or dotted. Yep. Sorry, I say both things. And then if it's greater than, our shading is going to be above that. So we'd shade just this little part of the grid here. All right, so if number 5 is our horizontal line because it only had y, then number 6 that just says x is less than or equal to -3. Well, this is going to be our what kind of line? Vertical. Remember hoi vux. So since you just have the x, that v at the beginning tells you that it's going to be vertical. We're going to have a vertical line that goes through -3. If I look at my sign, it's less than or equal to, so that's going to be a solid line. Oh, I forget this is not like notability that can make it straight. So we've got a solid vertical line. Now, this one is a little tough because you can't shade above or below a vertical line. But to make this inequality true, the x's have to be less than or equal to -3. So where on the x-axis are the values less than -3? On the left side. Very good. So we're going to be shading the left side of the grid because that's where the x values are less than or equal to -3. This is -4, -5, -6. Those are smaller than -3. Very good.